Welcome to another episode of Mighty Car Mods.
Now, we've been asked about DIY car tuning. You want your car to have more power, you want it to run better, and you don't want to blow it up?
We are going to show you how.
A wideband oxygen sensor gets installed into your exhaust pipe, and with some tricky electronics to operate it, will tell you the air-fuel ratio concentration that your engine is putting out.
So we're heading down to Canberra in the ACT to go visit Tech Edge and check out some of these widebands. Going to Canberra. Now, I just discovered that this little March has a feature that I didn't know about, and I have a feeling it's going to drive me insane.
So with 1 beep a second, that means Canberra's about 9,000 really annoying beeps away. If a car is running rich, then it's using too much fuel, and worse than that, if it's running lean, it means there is too little fuel and too much air in the engine, which can cause engine damage. Widebands used to cost an absolute fortune, but now you can get a basic one for around the same price as your average blow-off valve. It's a great way to get a closer look into how your car is performing. Tech Edge is an Aussie company and they are the wideband experts. Now these guys actually designed the Death Star. Well, they didn't actually design the Death Star, but they make really cool stuff. The workshop is packed to the brim with electronic gadgets to construct, test and refine their products. This is Adam. He designs and tests the circuit boards as well as programming the automation equipment Tech Edge used to build the unit. This machine places surface mount electronic components onto the circuit boards. Adam also creates the enclosures, which are purchased as blanks and then milled to suit the application. Every single process is automated to make sure every unit is perfect. Here, the Perspex screens for the displays are being cut to size on the mill.
It's our sensor test chamber. You stick its sensor and one of ours in this chamber. It's got a fan and some diffusing media. Basically side by side, our meter against the ETAS. Basically it outputs a serial data stream, which this thing interprets. If I squirt some ordinary cigarette lighter butane in one gas to displace the oxygen, that's very important. It doesn't measure the fuel load, it measures the oxygen concentration, so it doesn't matter what I squirt in there as long as it's not oxygen.
This is Peter. He's the director of Tech Edge and knows just about all there is to know about wideband oxygen sensors.
You can actually use these on a motorbike. So on your PC, you can just plug that in.
Peter took us around the block in his old Alpha to see one of the units in action.
To get to air-fuel ratio, you multiply lambda by the stoic value for the fuel, and in the case of unleaded, the agreed upon standard is that you multiply lambda by 14.7 to get the air-fuel ratio. This oxygen sensor is located where everything comes together, between the gear stick and the handbrake. If your car can do it, if it's a model that you can trick into using the narrowband output from our controller, it actually makes sense to have a wideband display, wideband controller. I can actually show you. You've got your standard narrowband sensor here. Typically that's going to be too hot, and for your car especially because you've got both turbo and a supercharger, it's going to be very hot where the narrowband sensor is currently located.
Well, where does it go?
Typically we would say about a metre from the outlet of the turbo. Just about there, or maybe even in front there. You really have to have your sensor pointing up at an angle, always perpendicular to the flow. So it's very important to, from a power point of view and from a longevity point of view to know what your mixture is.
We picked up our do-it-yourself wideband kit, and after dropping in on Kev to help him sort out some of his boost leak issues, it was 9,000 beeps back to Sydney.
I am Moog. To fit the sensor, we have to install a bung, which is basically just a nut with the right size thread to screw the sensor in. Keeping Peter's advice about the angle of the flow, we went down to our local exhaust shop to have it fitted up. First, a hole is cut in the pipe with an oxy cutter. Then the bolt is MIG welded onto the pipe. It's important that the sensor doesn't get in the way of your gear stick. This is quite possibly the most complicated kit we've ever had to put together. A quality soldering iron, or even better, a temperature adjustable soldering station is a must. The instructions are quite detailed, so if you've done a few kits before, you should be laughing. Build the kit up from the lowest profile parts to the highest. The connections take some custom mounting work to make them line up in the case. Follow the instructions carefully, and remember, if you're not up to building the kit, you can get a pre-made and tested unit. It's a really good idea to bench test the device using a regulated power supply at 12 volts. You can then load up the TechEdge software to check it's all running properly. We also decided to build our own display from a kit. With the unit tested, it's a matter of finding somewhere to mount the display and the controller. You can run the wire for the actual sensor up through the gear stick hole. The unit is wired up to turn on when the key's in the on position. It draws up to 3 amps, so you may need to run a relay or separate power from the battery. When activated, the controller heats up the wideband sensor so it can get an accurate reading. The display is showing lean because the engine's not running. As you can see, in second gear at full throttle, the March disengages the supercharger and the mixture immediately goes rich. This is robbing us of a little power up in the top end. It's a good idea to get your car run on a dyno, so you can get a baseline indication of your car's performance. Then the numbers will make more sense as to whether the car's running more rich or lean than it should. And you look particularly cool with a laptop on your passenger seat. Paul Walker style, danger to the manifold! Logging software can also be demoed and purchased from the wbo2.com website. With everything connected and the wideband controller powered on, you should see the fuel ratio on both the wideband display and the computer simultaneously. But it gets cooler again, because you can even log the output of sensors on your engine and compare them to the revs and mixtures. One way to find the sensor outputs is to go hunting around the engine bay. In our case, the Micro Sports Club resident Irishman Barry came to the rescue, sending through translated pinouts for the ECU. Tools required are the usual suspects for any auto electrical work. The first step was to find the wire that carries the RPM signal, so we can log this along with the air-fuel ratio. We spliced into pin 39, then wired the other end into our wideband controller. Then we spliced into our airflow meter output and our throttle position sensor, so this can all be graphed. Awesome. The logging software can then capture and display the data as a graph that looks something like this. We've now got an awesome, accurate way of keeping a close eye on what the March's engine is doing, and great peace of mind.
So, wideband oxygen sensor kit, awesome way to keep an eye on your car's tune.
Now, if you don't want to make one yourself or you don't have time, you can buy them pre-made, ready to go. We'll see you next time.